Space is a vast and mysterious realm, full of wonder and awe. It stretches beyond our imagination, a seemingly infinite expanse that has fascinated humanity for centuries. From the earliest stargazers to modern-day astronomers, the cosmos has always been a source of inspiration and curiosity. When we imagine space, we often picture distant stars, swirling galaxies, and perhaps the occasional spaceship soaring through the cosmos. These images, often popularized by science fiction, paint a picture of a dynamic and bustling universe filled with activity and movement. However, there's one crucial element missing from this common portrayal: sound. In the vastness of space, there is an overwhelming silence that pervades everything. This silence is not just a backdrop, it is a defining characteristic of the cosmos. Unlike the hustle and bustle of our planet, space is eerily silent. On Earth, we are surrounded by sounds, from the rustling of leaves to the roar of engines. But in space, there is a profound stillness that is both awe-inspiring and humbling. This silence is not just an absence of noise, it's a fundamental characteristic of the universe, dictated by the laws of physics. Sound, as we know it, requires a medium to travel through, such as air or water. In the vacuum of space, there is no such medium. This stark contrast between the cinematic depiction of space battles with their roaring engines and explosive collisions, and the reality of a soundless cosmos, highlights a crucial scientific principle. Sound needs a medium to travel. In movies, we hear the dramatic sounds of space combat, but in reality, such sounds would be impossible. In the vacuum of space, where there's virtually nothing for sound waves to vibrate, silence reigns supreme. This silence is a reminder of the unique and often counterintuitive nature of the universe, a place where the rules we take for granted on Earth do not always apply. To understand why space is silent, we must first understand what sound is. At its core, sound is energy created by vibrations. Imagine striking a drum. The drum head vibrates, causing the air molecules around it to vibrate as well. These vibrations create waves of pressure that travel through the air, eventually reaching our ears, where they are interpreted by our brains as sound. These sound waves are longitudinal, meaning the particles in the medium vibrate in the same direction that the wave is traveling. This movement creates areas of high pressure, called compressions, and areas of low pressure, called rarefactions. The speed at which these sound waves travel depends on the medium through which they are moving. Sound behaves differently depending on whether it's traveling through a solid, liquid, or gas. In solids, where molecules are tightly packed, sound travels fastest. Think of how quickly a sound travels through a metal rail compared to the air. This is because the closely spaced molecules in a solid allow vibrations to pass through them with ease. Liquids, with their more loosely packed molecules, transmit sound slower than solids but still much faster than gases. In gases like the air we breathe, sound waves travel the slowest. The wide spacing between gas molecules makes it more difficult for vibrations to propagate, resulting in slower sound speeds. Space, unlike our planet, is a near-perfect vacuum. This means that it's almost entirely devoid of matter with just a few stray atoms per cubic centimeter. While this might seem like a subtle distinction, it has profound implications for the transmission of sound. Without a medium to carry the vibrations, sound simply cannot exist in the vacuum of space. This lack of a medium is the fundamental reason why space is silent. Electromagnetic radiation such as light and radio waves can traverse the vacuum of space because they don't rely on a medium for propagation. Sound waves, however, are fundamentally different. They are mechanical waves requiring a medium to transfer their energy. Section 5. Whispers from the Cosmos, Gravitational Waves. While traditional sound waves cannot travel through the vacuum of space, other fascinating phenomena can be considered analogs to sound. One such phenomenon is gravitational waves. These ripples in the fabric of space-time itself are generated by some of the most violent events in the universe, such as the collision of black holes or the explosion of supernovae. Predicted by Albert Einstein's theory of general relativity, gravitational waves were first detected in 2015, ushering in a new era of astronomy. Although not sound waves in the traditional sense, gravitational waves carry information about the universe in a way that is somewhat analogous to how sound waves carry information about our surroundings. Another way we can hear the universe is through sonification, the process of converting astronomical data into sound. This innovative technique allows us to perceive the cosmos in a completely new dimension, transforming data points into audible experiences that can be both informative and mesmerizing. By translating data from telescopes and other instruments into audible frequencies, scientists can explore cosmic phenomena in a new and engaging way. This method not only aids in scientific discovery, but also makes the data accessible to a broader audience, including those who are visually impaired. For example, data from the Chandra X-ray Observatory, which observes black holes and other energetic objects, has been sonified to create eerie and beautiful soundscapes. These soundscapes can reveal the dynamic and often violent nature of the universe, offering a unique auditory perspective on phenomena that are otherwise invisible to the naked eye. Sonification allows us to experience the universe in a way that our other senses cannot. By converting data into sound, we can detect subtle variations and patterns that might be overlooked in visual representations. This auditory approach can lead to new discoveries and a deeper understanding of the cosmos. It can reveal hidden patterns and relationships in data, providing new insights into the workings of the cosmos. For instance, the rhythmic pulses of a pulsar or the chaotic signals from a black hole can be better understood when heard rather than seen. While not a replacement for traditional scientific analysis, sonification offers a powerful tool for communication and outreach. It bridges the gap between complex scientific data and public understanding, making the wonders of the universe more accessible to everyone. Allowing the public to experience the wonders of astronomy in a visceral and unforgettable way. Through sonification we can share the beauty and mystery of the cosmos, inspiring curiosity and wonder in people of all ages and backgrounds. The silence of space poses a unique challenge for astronauts. Unlike on Earth, where we can communicate effortlessly through sound, astronauts must rely on radio waves to converse with each other and with mission control back home. Radio waves, like light, are part of the electromagnetic spectrum and can travel through the vacuum of space without a problem. Inside their spacecraft, astronauts can talk normally as the cabin is filled with air. However, during spacewalks, they rely on radios built into their spacesuits to communicate. These radios transmit and receive radio waves, allowing astronauts to stay in constant contact, even in the vast expanse of space. The silent nature of space has profound implications for our understanding of the universe and our exploration of it. In the vast empty expanse of space, there is no air to carry sound waves, making it a realm of complete silence. This silence is not just an absence of noise, it is a fundamental characteristic that shapes our approach to space exploration. It affects the way we design spacecraft, ensuring they can operate in the vacuum of space without the need for sound-based communication. Engineers meticulously work on spacecraft, considering every detail to ensure functionality in the silent void. The way we communicate with probes and rovers sent to other planets is also influenced by this silence. Instead of relying on sound, we use radio waves and other forms of electromagnetic communication to send and receive data. This is crucial when searching for signs of extraterrestrial life, as we must adapt our methods to the unique conditions of space. For example, when searching for life on other planets, scientists must consider that sound might not be a reliable indicator of biological activity. They focus on other signs, such as chemical signatures, that could indicate the presence of life. Instead, they focus on detecting chemical signatures and other evidence that might point to the presence of life. This involves analyzing planetary data and looking for anomalies that could suggest biological processes. The silence of space also underscores the vast distances involved in space exploration. Spacecraft travel through immense stretches of emptiness, highlighting the isolation and the challenges of long-duration missions. Even if we could shout loudly enough, it would take years, centuries, or even millennia for our voices to reach the nearest stars. This illustrates the incredible scale of the universe and the patience required for interstellar communication and exploration. The silence of space, while initially disconcerting, offers a unique perspective on our place in the cosmos. It reminds us of the vastness and emptiness that surrounds us, but it also highlights the preciousness of our own planet, teeming with life and sound. In a universe where silence is the norm, the symphony of life on Earth takes on a profound significance. Understanding why space is silent allows us to appreciate the intricate workings of the universe and the fundamental laws of physics that govern it. It's a reminder that our human experience is just a small part of a much grander cosmic tapestry, full of wonder, mystery, and profound silence.